Hello. So I'm going to start by creating a problem where we've got a little data set, and imagine we run a reptile farm. Okay, so we've got some snakes and they're all of different lengths. Right? We've got maybe five snakes. You'll have to forgive my terrible drawing. So we've got a baby snake, got daddy snake, we've got a mummy snake. This is totally what snakes look like, by the way. This is biologically accurate. And then we've got a tiny little baby snake. Okay. And approximately their size in inches are, let's just say this one is 4. And then let's just say this one is 8. And we'll say this one is a little bit smaller, so it's 3. I'll call this one 7. And I'll say this one is 2. Okay. So the purpose of statistics is we have something that exists in the world, right? We have some set of objects, and then we create some set of numbers that in some way has a relationship, right? This relates to this, this relates to this, this relates to this, this relates to this, and this relates to this, okay? This describes some characteristic. You'll sometimes hear it called a variable that relates to these things that exist in the real world, okay? And the nice thing is, once we have this, we can not just take the numbers themselves, we can actually start doing some things that tell us something about the whole group of them. So one thing that you will come across often is the average, right? Which is a way of saying, you know, if we wanted to describe how big they are generally, what is the closest way of doing that, right? What is the best way of describing how big they are? If we wanted to be truthful and say, you know, if somebody asks us how big is a snake, we might think, well, they all change, they all vary, right? Like it goes up, it goes down, it all changes snake by snake, but we could give them some number that gives them an idea of how big snakes are in general, like what's approximately realistic, and it would probably be about 4, right? They're probably around about here overall. A little bit bigger than the baby ones, a bit smaller than, you know, the parent ones. None of them are actually like a size of 5, but they're you know, not far off 5, right? Most of them are not that far off 5. So the average is sort of, you know, some value that represents the whole group. You may have heard it referred to as the mean, which is another way of saying the value essentially in the middle. There are actually a few different kinds of averages you can compute. So the one that I will show you, the most common one that people refer to when they say the average, is where you add all of these up and then you divide by the number. Okay, so how many are there here? Well, there's 5, right? We'll just label them. Okay, there's 1 here. This is our second one. This is our third one. This is our 4th one, and then this is our 5th one. So what we're going to do is we're just going to add these up as we go. So we've got 4 plus 8 plus 3 plus 7 plus 2. Okay, so let's do this what they call cumulatively. 4 plus 8 that's 12, right? And then the next thing we've got is 15, and then we've got 22 at this point. And then, I don't know, I'll put another 2 there, forgive me. And then we've got, messing up my notation now, but okay, we've got 24 at this point, right? Just ignore my mistakes. So we've got 5 of these. We've got 5 of these. So what we're going to do is we're going to take our 24, and then we're going to divide it by 5, okay? And that works out to be 4.8. You may also see a number represented like how many 5s goes into 24. Well, 5 goes into 24 times, and then you've got 4 over 5 left. So you may also see this sometimes, okay? These all mean the same thing, right? So that's our average. And if we go back to our snake farm, 4 is here, right? 4 is here, and our average is a little bit more. So what we're saying is the mean exists here. Okay, now mathematicians like to impress people because we're egotistical. So this hopefully has been quite simple to understand, but you may sometimes see a slightly confusing notation. And you get this, and one of the letters is from the Greek alphabet. Okay, this is something called sigma. And if you see this, I'll go through this and explain what it means. But this is literally what we just did, so don't be scared of this. It's just a way of mathematicians trying to impress others by look at how cool we are with our confusing language. So let's just actually explain these parts so you're not looking at this and thinking, what on earth are we doing? For a start, this Greek character, what it means, and you can look this up, this is in the Greek alphabet. What this means is I want to start at position number 1, right? And I want to go through however many items there are in our collection, right? So that's the start, which in our case is 1. And this is the items in the collection. Items in collection. And what we're going to do is we're going to say for every item, we're going to take away the average value. And what you essentially get if you do that is, in this case, you've got 4, and you will take away the average that we computed earlier, right? So for each of these you go through and you take away 4.8 from them, and then you add the whole thing up. So when you do variance, you do something a little bit different to that, where essentially it's the same thing, but what you do is you are making this, I'll just move the camera a little bit. What you do is you do this bit here, right? So what we're going to do is we're just going to go through and we're going to, for every item in our collection, we're going to do something to it. And we're going to do this thing of where what we do is we take away the average, okay? And then we've got this thing, which I'll explain in a second. And then we've got another step, right? So what is this? Well, what this is telling you to do is to take every element in our collection, take away the average from it, and then when you get the values, you times them by themselves. So if we actually do this with our collection, right, our average was 4.8. So what we've got to do is, I'll just move my camera slightly because this is probably not too easy to see. What we've got to do is we've got to say, okay, well, we know this average, we worked it out earlier, okay? So if the average equals this, 4.8, we're going to go through every single item in our collection and we're going to take away 4.8 from it, okay? And then we're going to do this thing over here, which is what they call squaring, all right? So we'll times it by itself. And what you get when you do this is you've got 4 minus 4.8, right, squared plus 8 minus 4.8 squared plus, what's the next one? It's 3, right? 3 minus 4.8 squared plus 7 minus 4.8 squared plus 2 minus 4.8. Oh, I should have put that outside. Squared. And that's going to roughly be equal to, and I'm going to do this roughly just for the sake of doing the numbers. You'd actually do this probably with a calculator. I'm going to say that roughly equals 4 minus 5. So that roughly equals, actually, 4 minus 4.8. I know what the square of that is. 4 minus 4.8 is 0.8 squared. 8 squared, which is actually 0.64. And then we've got 3.2 squared plus that's going to be about minus 2 squared. This is going to be about plus 3 squared. And then this is going to be about minus 3 squared. Okay. Now, the nice thing about when you square numbers, if they're odd, you can ignore them, okay? So where we've got a minus here, and where we've got a minus here, this is all going to become positive, okay? So this is all approximately going to be equal to, my notes are getting a bit cramped, so you'll have to forgive me that. Okay, I'll just divide this off just so. Right, that's going to be approximately equal to 0.64 plus about 9. Right, 3.2 squared is about 3 squared. It's about 9. You could sit down with a calculator and you know, work it out with a decimal point, but I don't care about being super accurate. But your teacher might tell you off if you don't. So if you've got any homework, do bear in mind, you know, you've got to not simplify this. Okay, you need to square 3.2, not 3. But just for the purpose of the video. Okay, so what we've done here is we've squared these numbers, right? So don't think about these as quantities. Don't think about them as numbers. Think about them as a direction, right? If you've got a path, okay, and I say to you, all right, you can either go that way or you can go that way, right? And this one is positive and that one is negative. If I give you 2 of these, like if you think of this one as a change of direction, if you change direction twice, right? So we're going this way in the beginning, then we change direction once, and then we change direction twice, we end up going in the same direction, right? So this is what squaring is. It's basically saying if you are going in a positive direction, keep on going in that direction, right? But if you're going in the other, if you're going in a change of direction, you're going backwards. But then I've got two changes in direction. I end up going forwards, right? It's this thing. And that's why we square when we're doing variance, because we don't want to go forward and then back and then forward and then back, right? We're working out how much different are each of our snakes compared to the perfect snake, okay? And what you do is once you've got this, is there's actually another step where you add it all up and then you divide it by the number of items in your collection. So in this case, what we end up with is 0.64, 9.64, 13.64, 22.64, and then 31.64. Okay, if you add them all up, that's what you get. And then you're going to divide this by 5, right, to complete this thing. Okay, we left out this step of dividing it. So when you see that, all it is saying, you know, first off you need to work out what the average value is, which is what we did here. We added everything up, we divided it by 5, we got this, and then we're like, okay, we know that, so this is now 4.8. We're going to go through every item and we're going to do this, okay, and we're going to get these values. Then we're going to square them and add them all up, and then finally we're going to divide them by the number of items we have, and that will give you this, because right, that will give you this, and 5 goes into 36 times, 5 goes into 1 0.2 times, and then we've got 0.12 for this, and then we've got 0.08. Okay, so what you will then have is 6.4. Oh no, I made a slight mistake in there. Okay, but that's essentially your operation in here to do this. So I just put approximately equals that, and that's how you calculate the variance in there. And this is essentially what you're doing whenever you see this. That's essentially what you're doing whenever you see this. You're just calculating whatever the average is for every item, you're taking it away, and then you are going through and adding them all up. And this looks confusing, but remember, all you're doing is first calculating this, and then you are dividing it by the number of items that you had, right? So as long as you follow it like a recipe, number 1 is going to be 1. Take the average, okay? Number 2 is going to be take average away from each item. And then once you've done that, you then square them, okay? So you can think of this as ignoring, ignore the minus. You're going to have to forgive my terrible handwriting. That is ignoring the minus. And then once you've then add all these numbers together. Right. Once you've added everything together, and then divide by the number of items. And that's it. You're done at that point. And that's how you do the variance. The other one that you might see is something called the standard deviation, right? And you may actually see sometimes this is n minus 1. You may come across n minus 1, okay? But it's essentially the same thing. Instead of dividing that by 5, you divide it by 4. There is something called the standard deviation. If you remember when we did this, we got about 6.4, right? Now, that's actually more than the median, remember. Our average snake was about 4.8, right? And we're not actually measuring this in terms of the entire snake length, right? We actually want to say how big on average is this distance, right? And it's actually probably not a lot. Like these ones don't actually change that much relative to one another, yeah? There's probably only a small amount of change in here. So if we've got about 6.4, we've got 6.4 because we did this squaring thing over here, right? We wanted to get rid of the negatives in here, so we squared them. But now we've got a number that doesn't really represent how much these snakes vary, right? The variance actually doesn't represent very well how much these snakes vary, right? Not in reality, okay? So you have to actually do something called a square root, which is where you find out, you know, if we took some number, and found out what is that number times itself, what is it that gives us 6.4, right? And this is called the standard deviation. This is to give us some actual idea relative to the size of these animals, how much they kind of vary. Now, I'm not going to do this off the top of my head, so again, it's going to be another approximate answer. But if you times 2 by itself, you get 4. And if you times 3 by itself, you get 9. So 1 is too small and 1 is too big. So what about 2.5 times itself? Well, that actually gives you about 6.25, right? So I'm going to say that this is about 2.6, right? So does that seem reasonable? Well, if we have a think about it, okay, that's a gap of 4, that's a gap of 5, that's a gap of 4, that's a gap of 5. But actually these ones don't vary that much, right? There's a gap of 1 in there, there's a gap of 1 in there. And, you know, if we look in here, it probably is, you know, yeah, okay, there's a big jump here. It's like 1, that's about 5. You average them out, it's about 3, right? You can sort of see that actually the idea that they, you know, sort of vary on average by about this much. Their deviation, that's what they call the standard deviation, is about 2.6. That sort of does actually seem reflective of this. So get comfortable with this. Okay, it's literally just working out this number and then doing a few more things with it. You know, I've described it over here, the steps, and then, you know, if you want the standard deviation, find the square root. Okay, and and that's the whole process. Okay, now something you should know is the standard deviation is just the variance before you square root it. That's all they are. Okay, so this gives you the variance, and this whole thing over here is the standard deviation. Okay, it's literally just the extra 6th step for the standard deviation, and that's it. That's the whole process for calculating a standard deviation and variance.